Okay, so welcome, and now we're going to talk about cotangent. So again, remember, cotangent is a reciprocal function for tangent. So that's going to help us, because if we know how tangent behaves, then we can find out how cotangent behaves. Now notice that since it's reciprocal, when tangent is increasing, okay, cotangent is decreasing. Okay, and so what we end up getting is this sort of graph here. Okay. Now, also, cotangent is undefined wherever tangent is 0. So where's tangent 0? Tangent is 0 at 0 and what? Any multiples of pi. So 0, pi, 2 pi, negative pi. So wherever tangent is 0, then cotangent is going to be undefined, and that's where we get our vertical asymptotes at. Okay. So again, other things that we've seen before. So we've got the stretching factor A. Now this is the basic general form, and this one includes the vertical and horizontal shifts. So this is the most general form. So again, there's going to be some similarities and some differences. Okay. So for example, they both have the stretching factor A, and they both have the period, which is based on pi divided by the absolute value of b. Okay. Now, the domain for the simple function is just going to be this. It's going to be basically everything except where there's a vertical asymptote, right? And where are the vertical asymptotes located? Well, all multiples of pi divided by the absolute value of b. So this is, again, the general case. Because if b is 1, then you just get the multiples of pi. But obviously we could be dividing by some value of b here. Okay, so what else? The range is going to be all real numbers. That's going to be the same. But notice here the domain is a little different because we've got this horizontal shift. So we're going to bring in the phase shift again, right? Again, the phase shift is a real easy way to know how far to the left or right without having to factor out the b, right? So because if you factor out the b, you get the phase shift here, okay? So that's where the phase shift comes from, because we want to see what's going on with x. And so the way to do that is to factor out b, and then you get, in parentheses, you get x minus c over b, which tells you how many units to the right or left you're actually shifting, okay? So, now, so the domain is going to be basically all real numbers except where the asymptotes occur. So in this case here, the most general case, the asymptotes are going to occur at the phase shift plus a multiple of pi over the absolute value of b, okay? So the only difference is you're adding this phase shift in here, okay? And again, remember, this is just saying, hey, for all multiples, integer multiples, right? Because k is an integer, so all integer multiples of pi over the absolute value of b, okay? And so that's those are the important characteristics that we're going to use to analyze and graph these variations of cotangent. Okay, that's it. So let's jump in and do a few examples and wrap it up. Take care.